In the last lesson, we built a parts tree, a hierarchy where specific parts subsetted abstract placeholders defined by a parent. Now that we have modeled the parts, in this lesson we need to define the connection endpoints and the rules that control these connection protocols. In SysML v1, you had to carefully choose between proxy ports typed by interface blocks and full ports typed by block types, and manage flow properties with explicit manual direct management. In SysML v2, however, ports and interfaces follow the same definition usage pattern used throughout the language. Ports define the endpoints where parts connect, while interfaces define the connection protocol between them. And while port conjugation existed in v1, SysML v2 leans into it much more elegantly to eliminate redundant modeling. You define a port def once. Then you use the conjugation operator, the tilde symbol, to mathematically flip the direction of the interaction features in that port. Features with direction in instantly become out, and vice versa. Features with direction in-out or no direction at all remain unchanged. Let's break this down. To model a precise connection in SysML v2, you need to define two distinct concepts. The first is the port def, which represents the endpoint. Think of it as the shape of a pin or a socket. It specifies interaction features such as the capacity to receive items, data, or energy using the in keyword, or send them using the out keyword. The second is the interface def, which establishes the connection protocol. This is the type, or the blueprint, of the connection itself. It defines the structure of the wire or protocol that links two ports together. Crucially, interface def is not the physical connection. Rather, it is the definition of what a valid connection looks like. Now let's look at a concrete example by modeling a fueling interface between a fuel tank and a refueling nozzle. The key thing to notice here is the tilde operator. Instead of creating two separate port definitions for the tank and the nozzle, SysML v2 lets us define the fueling port once and automatically reverse its interaction directions using the conjugation operator. There are three core concepts to understand from this code. The first is what the interaction features actually mean. In port def fueling port, the line in item fuel does not mean fuel is constantly flowing through the port. It defines an interaction feature, specifically the capacity of that port to accept fuel objects. The actual flow is a dynamic behavior modeled separately as a performance. The second concept is conjugation precision. The tilde operator does not reverse everything about a port. It specifically reverses the direction of interaction features. So an in item becomes an out item, and an out attribute becomes an in attribute. This creates mathematical compatibility between the two sides of the connection, the nozzle as the provider and the tank as the consumer, without requiring us to manually write a mirrored port definition from scratch. We define the port once, and conjugation automatically handles the opposing side. The third concept is the important distinction between interface def and interface usage. The interface def is the protocol. It does not represent an actual connection in the system. Instead, it defines the rules of a valid interaction. Interface usage, on the other hand, is like a cable, representing a specific instantiated connection between parts in a system. In later lessons, we will use connection usages or the connect keyword to realize these interactions. For now, think of it like USB-C. The interface def is the USB-C specification itself, while the interface usage is the actual cable connecting two devices. So how does this look when we render it in a compliant SysML v2 visual tool like SysModeler? The code translates seamlessly into the diagram you see here. Your part definitions, like the fuel tank and the refueling nozzle, are rendered as standard boxes. On the boundary of the fuel tank box, the tool automatically places a small square representing our filler cap port. If you look at the refueling nozzle's boundary port, you will see exactly how the conjugation is visualized. The tool clearly identifies the conjugated side by placing a tilde right in front of the type name, labeling it as nozzle:tilde fueling port. It is a clean, immediate visual confirmation that the plug and the socket are exact mathematical mirrors of each other, perfectly prepped and ready for a connection. Before we wrap up, here is a quick side-by-side recap with V1. The interface block stereotype in V1 is replaced by interface def in V2. The proxy port in V1 becomes a port typed by an interface in V2. A flow property with direction equals in V1 is now written as an in item, a proper interaction feature. And the is conjugated equals true property in V1 is replaced by the clean native conjugation operator tilde. That is the power of SysML v2's approach to ports and interfaces. A single, reusable port definition, a protocol-based interface definition, and one operator that eliminates the need for redundant mirror definitions. In the next lesson, we will look at connections. Now that we have the ports as our endpoints and the interface definition as our protocol, the next step is to actually wire them together, using the connect keyword to establish the topology of the system. See you there.